Hello and welcome to Swedz latest video. In this tutorial I'll be showing you how to create a trainer for your favorite games with a user-friendly GUI. In the past I've made a tutorial on how to create a trainer for 32 and 64-bit applications, but I didn't include any design elements.
Wow!
While you can definitely follow this tutorial without watching the previous one, I recommend going back if issues appear. Throughout this video, we will cover 3 main steps: finding the address of the ammo, discovering which instructions are responsible for changing the ammo, and designing and writing the trainer itself. As always, read the terms of agreement for your game before you make the trainer. Alright guys, so we want to find the address of our ammo. In the game, I have 17 bullets in the magazine. We will search for the value, which is 17, and then search again for a new value. So we shoot a gun, it's a new value, we search for that value to filter out the addresses that doesn't point to the ammo value. So it was 17 at first, we will search for 17, we will shoot 2 times, it's 15 now, search again, we have 140 addresses, still a lot of addresses, and we will shoot again, 14, still no less. So if you're stuck with amount of addresses, you might want to start checking the addresses out. This time we have a lot of static addresses, but what I'm looking for is dynamic memory. This static memory often doesn't work. It's often display and engine stuff. So if you're trying to find the actual address that holds your value, it most probably will be these dynamic ones for the main module, or in Half-Life and Counter-Strike and so on, client.dll. But check the dynamic addresses first, then the static ones, and you should find it by then. I will take the dynamic addresses first, put them down here. I will change these ones to freeze, and I will shoot in game. It went down to 13 and it didn't go back to 14, which means these ones doesn't work. The shortcut to freeze values is by selecting one, shift, select the next ones, then press space. That will make the values freeze and or write them to the original value or the captured value at when you checked the freeze box. So these ones didn't work, we can delete them. We will check the last 2. So kind of go half of the addresses. If there's a lot of addresses, the game might crash or the process might crash. So keep it to a reasonable amount of addresses that you freeze. So we freeze the last 2. We shoot 12. So the value didn't change and we can remove these ones. Now we only have 2 addresses left, and we can freeze those 2 to check that it's actually there, and it's going back to 12. Probably one of these ones, right? We will check off the last one. It still goes back to 12. This means it's our first address, so we will call this clip, or ammo might be more easy. We will only keep the working address in our address list, and now instead of having to freeze the value, write it all of the time, we can change it back to 30, which is the max ammo, and it changes to 30. Amazing. What I was going to say is we don't want to constantly be writing to this address. Instead, we want to change the code that writes to this address. Because if we change the code, it will automatically not have to update. We don't have to rewrite it because we're rewriting the instructions. How we can find these instructions is by right-clicking and then find out what writes to this address. This will attach the debugger to yes. And now you should pick the ones or the instructions that only occur when you're losing the ammo. So I shot 3 times. This instruction happened 3 times. Good stuff. When you have found the instruction, go to show disassembler. And here you can right click, replace with code that does nothing. Click OK, and now it should say 90, or a lot of 90 bytes. This 90 means do nothing or nope. It will just skip these lines. It will not care for them. And because we replaced the instructions that affect our ammo, we can now shoot and the ammo doesn't go down. If we restore it with original code, we will lose ammo again. So we want to do this in our trainer and with a checkbox, so we can check for infinite ammo and uncheck to replace these bytes with original ones. That means we will have to write down the address, the bytes, and the amount of knobs. So first thing, we will copy the module plus the address. And to do that, you can right click, copy the clipboard, addresses only. We will paste it there. And now you can replace with code that does nothing. Here, write down the amount of knobs you see here. So we have 1, 2, 3, 4, 5, 6. We have 6 knobs. We will write the knobs in this manner. That's 5, that's 6 knobs. 1, 2, 3, 4, 5, 6. And after that, we will restore with original code. When the original code is back, we will write the bytes in the same amount of the knobs. So we will write down here, it says 89, 89, 86, 8C, and now 0, 0, 0. So we have our bytes, we have our knobs, and now we're ready to write our application. And I will see you after a short break. Okay, so now I'm back. It was instant for you, but I took a couple of minutes off. I'm at Visual Studio creating a new project, and I will choose Windows Forms app. You will do the same, and I'll call it CZ or Z Trainer. Click next. Make sure you use .NET 6. Don't use anything else. I don't care why you might use something else. If you want to follow this this tutorial, use .NET 6. Once you're here, I'll let my computer load. It's slow. It's old. Once we're here, we can see the designer, but we will go directly to project, properties, and please now choose the correct platform. So here it's loading properties, build, platform target. choose the correct target platform. If you're using 32-bit, click the 86. If you're using 64-bit, use the 64. End of discussion. We have our form here, but we want a checkbox for our infinite ammo. Let's find the toolbox. Not toolbars, toolbox. And we will search for checkbox. We'll drag it and let's change the text to match our need. There we go. I'll make it the form a bit smaller. I'll keep some space so we can add a label up here. But for now, we have a form, we have a checkbox, and we have, yeah, that's about it. Now, you will double click on the form, and it will bring this load method. Once we're here, we will add Swedz. I might have been a bit fast, but go to manage NuGet packages. We will browse and then add the correct memory class for the correct platform. I'm using 32-bit. I will use Swedz 32. If you're using 64-bit, search for Swedz 64. I accept. So on. There we go. If it says mismatch and so on, go back and change the platform again. Now, right, using Swedz and the correct platform. Now you should be able to use the Swedz class. We will declare some variables here. We will declare, first of all, the Swedz like this, and the base pointer of or the base address of the module. I have my notepad here. It's the cc.dll. We will copy that. Actually, we don't really need it right at this second, but copy it until further. We will call this the module base. Now go to the form method. We will give them the values. So Swedz equals new Swedz, and pick your process name. So mine is hl.exe. We will use everything before the .exe. So not like this, like this. After that, we will give module base the value of Swedz.get module base, and then string your module. Really easy stuff. This will store the module base in our variable, and now we can write to our address. Let's go back to the designer, double click on the checkbox. It should bring out this checkbox underscore checked change, which means some of the either unchecked it or checked it. Thereby, we will need to have a if statement. If checkbox 1.checked, that's the name of the checkbox. If it is checked, we want to have infinite ammo right. And the way we did that was with writing nops to the address. So let's do exactly that. Swedz.nop now. And we have our module base. Let's go back to Sheet Daniel. cc.dll plus 9b255. So it's the module base. cz plus 9b255. I wrote it down in the notepad. and I'll add 0x before it. Nop takes 1/3 argument, which is the length, which means how many nops. We had 1, 2, 3, 4, 5, 6 nops, so we will write 6. There you go. For option 2, it's write back the original bytes. So let's write back the original bytes. It's the same address, so we can copy this. But now we have a new byte array that we will have to write down. We will copy the original bytes like that, copy, paste, and we're done. So if it's checked, we nop. If it's not checked, we write back the original bytes. Let's try and run it and see if there are any errors. If you have come this far and it didn't crash saying there's a mismatch, good for you. Sorry for that. I don't know what that was, but we will open Sheet Onion and our game and check in the memory. So keep a close eye on the bytes. We'll open our application, and when we click the checkbox, these ones should turn like the nops, or when we right click and selected replace with code that does nothing. Amazing. What are you looking at? So we're doing the same thing, but now with our own application, and we don't need to have Sheet Onion open. We don't have to have a script and so on. We just need our trainer. Let's check that in game it doesn't crash. We have infinite ammo. Let's find some